Hi everyone. Today we will discuss about graph data structure. Graph is nothing but a collection of vertices and edges. Here, vertices we can also call as nodes. Now, uh, suppose take vertices 0, 1, 2, 3, 4. Here we have vertices are 0, 1, 2, 3, 4. Now edge is nothing but represented by pair of vertices. These are edges. Now if you write here, there is edge from 0 to 1. So we can represent the graph as vertices and edges. There can be uh, edges can be empty set, but vertices not empty set. It should not be an empty set. Then we will discuss some types of graphs. There are many types of graphs. If you take directional, if you take directional and undirectional, here from 0 to 1 is undirectional. There is no direction, so we can say it is from 0 to 1, or from 1 to 0 we have the edge. So we can take that v as 0 and 1, and we can take that edge as 0 to 1, also as 1 to 0. Suppose if you have direction from 0 to 1, then it can be like that edge is equal to, it simply but 0 to 1 only. So for undirectional, there will be double the edges. For example, for this graph, if you want to write vertices, it can be 0, 1, 2, 3, 4. If you want to write edges, then it will be 1, 2, 3, 1, 2, 3, 4, 5, right? So 5 into 10, 10 edges will be there. That is 0 to 1, 1 to 0, 0 to 2, 2 to 0, 2 to 3, 3 to 2, like that 10. If you take directional, then it will, there will be only n edges. That is only 0 to 1, 1 to 4, whatever the direction is there. There are many other types of graphs also there. This is one classification, that is directional or undirectional. There is other classifications like cyclic, weighted, unweighted graphs, connected, disconnected graphs, simple, multiple graphs. Now let's discuss representation of the graph using arrays and linked list. We can represent in many ways. Now we will discuss representation of the graph using arrays data structure. For that, first let's take uh, vertices 0, 1, 2, 3, and 4. And now let's add edges to this. Let's do for uh, directional graph. So suppose there is an edge from 0 to 1, 0 to 3, 0 to 2, 2 to 3, 1 to 4, 3 to 4. Now we will simply take first that vertices. How many vertices we have? 1, 2, 3, 4, uh, that many vertices. Then we will then take an 2D matrix, that is that int that matrix of 2D size v. Then we will simply do operations. First we will do add edge. We will simply call that function, and we will do that add of first let's understand the representation in 2D matrix. That is it can be like 0 1 2 3 4, and again 0 1 2 3 4. Now uh, we need to observe, whenever there is an edge, we will simply make there itself it as 1, and the other by default it will be 0. So from 0 to, suppose this is source, this is destination. From 0 to 1 we have edge, so we will make that as 1. And from 0 to 3 we have edge, so we will make that as 1. And 0 to 2 we have edge, so we will make it 1. So here we will simply take array of source and destination, will make it as 1. So for everything, for 1 it have 1 to 4, right? Then for 2 it have 2 to 3. For 3 it has 3 to 4. For 4 there is no edge, so like that for every edge we will make it as 1. And similarly the remaining operations, if there is a if we want to check it as edge or not, means if there is a 1, we will think as there is edge. If it is 0, we will think there is no edge. Also we will make, we can remove the edge also. We'll simply make that 1 as 0, and we can at the end we will we will print the total array. So I will directly go with the implementation part. This is the implementation part of the graph data structure using arrays, that is matrix. So you can pause the video and check for the logic. So here I'm simply taking array matrix, and I'm simply checking first add edge from 0 to 1, 0 to 2, 0 to 3, 1 to 3, 1 to 4, 2 to 3, 3 to 4 for directional. And then here for adding edge I'm simply taking that source destination, making as 1. And for printing I'm printing, and if I want to check there is edge or not, I will simply take if there is 1, or else there is 0, it will return 0. If I want to remove the edge, means I will make that as 0. This is for directional. If you want to make for undirectional, I mean both sides, we will simply take the reverse, right, uh, array of destination and array of source. This thing also we can make it as 1 for undirectional, for both, when the edge is from both sides. So so now I will run this code. So here it is. I have uh, added the edges from 0 to 1, like everything. So the matrix representation is like that, 0 1 1, like this. The same representation we have tried to put here. That is whenever the edge is there, we will make 1, or else it will be 0. So this is the representation of uh, graph data structure using uh, adjacent using adjacent matrix. Now we will discuss graph data structure construction using linked list. If you not watch linked list, I will put in the course, please watch it. So I will take what is says 0 1 2 3 4. Then I will take edges. I will take first directional graph. So there is edge from 0 to 2, 0 to 1, 1, 0 to 3, 2 to 3, 1 to 4, 3 to 4. Now, okay, I will be represent means I will take first that class node. There I will take int data and node nest. Then I will create object that is node that list array that is equals to new list of I will take size how many, that is 5. 5 uh, vertices we have, right? So that means we have list of 0, list of 1, list of 2, list of 3, list of 4. So now whatever connected to adjacent nodes we will add. Suppose there is a 0, there is a, it is connected to uh, 0, right? Then it is connected to 1, and again 0 also connected to 3, and again 0 is connected to 2, like that. Similarly for 1 it is connected to 4, and that's it. If you take 3, 3 is connected to 1 is connected to 4, and 3 is connected to 4, and that's it. If you take 2, 2 is connected to 3, and also 2 is connected to that seat. So like that, whatever there we will represent like this. Now we will make add edge. Simply first we will take a new node, and then we will pass that value 0. Then we will make this as suppose a list of 0 will point that address. Then again if you add a new node, then we will add the we will link like this addresses. So we'll simply link, that is taking node new node, and new node dot data equals to the value you're passing. Then that new node dot nest uh, is equal to, we will add will connect to the list of 0, list of 1, whatever list of that I. Then we will make that make the connection. Here simply we are doing adding linked list at end. So similarly it's the all operation will similar to how we do linked list operations. Like if you want to do as edge, like if you want to find there is an edge from 1 to 4 or not, simply you will check there is edge from 1 to 4. If there is a link is there, you can say the link there is an edge. Similarly the search operation is also same similar to the operation linked list. You will see that from that source to destination, if there is a link is there, connection is there, then you can say the search is found. Similarly there is an delete operation. So delete operation also it's same operation, linked list operation. You can simply, for example, if you want to delete 1 to 4 connection means, you can simply the link you will break. Suppose that whatever, like it will be like that object equals to object dot nest, or like object dot nest equals to object dot nest. So you will break that link through delete operation. So let's run this code on editor. So you can pause the video and check for the logic. So you have taken the adjacency list 5. Then here I'm simply making adding the edges from 0 to 1, 0 to 3, 1 to 3, 4 to 4, 3 to 4, like this. Then here I'm adding the edge. Says like I said before, adjacency of source if it is null, So code, you can pause the code and check it. So if I run, so I'm adding edge like this, then the representation will be like this. So 0 to 1 2 3 G 1 2 3 4 2 2 3 3 2 4 4 to null. So this is the code. I'm printing the graph like similarly how we print in linked list. I'm taking each node and I'm printing up to null. So here we did for directional graph. If you want to do uh, undirectional graph, you will simply do here. I will tell you two things here. For example, in here in the previous, in the directional graph, we did like this, right? We added the for example, this is list of 0, list of 1, we added at the end, or but it will take order of k operations, right? So we will simply do list of 0, list of 1, list of 2, list of 3, and list of 4. We will simply add at the beginning whatever that one edges are there. So it will take a order of one. Now if we want to discuss undirectional, that is now in the code we will simply take that new node, that new node dot data is equals to destination we are taking that, and we are doing then a new node dot next is equals to that list of that zero something. So the same we will take for new node dot data is equals to source, and then that new node dot next equals to whatever the connection point. So it's quite similar like how we take in the array, right? We have taken first array of source and destination, that we're making one. For by the undirectional, we are simply taking destination and source also one, so we are doing for both. So here also we will do for both. So and the remaining operations like has edge, remove edge, set, print, all the operations are similar. So this is how we will construct a graph data structure using linked list. Now let's discuss the comparison between that adjacency matrix and adjacency list. That is when to use adjacency matrix and when to use adjacency list. For example, if you take and dense graph like this, suppose it will be like this. This is 0 1 2 3 4. When it is a dense graph, that is such that e equals to like that, that if it is like this, so then for it will be convenient to use adjacency matrix array data structure. That is that we have order of one operations, right? Whatever that as a added to add edge, if you check there is an searching operation, if you check there is an edge or not, if to remove edge, like print edge, everything. But when you talk about uh, just an spots graph like that, there is just the edges is like just almost equal to vertices. So then if you want to here add new vertex means then we need to again take new array and copy. So array is not the size is fixed, right? So then here the linked list, that is adjacencies, will be helpful here. So although this add edge set edges, if we, it will take order of k, but it will take order of 1 for adding nodes or vertices. So depends on the situation. If it is dense graph, we will use adjacency matrix. If it is use sparse graph, if we'll use adjacency list. So this is all about graph data structure.